The primary subclassifications we will use this semester result in 2 additional choices for each of the main types of variables. For categorical variables, the 2 subclassifications are nominal and ordinal. Ordinal categorical variables have some natural ordering among the categories, although differences are not precisely meaningful due to the categorical nature of the data. Nominal categorical variables do not have a natural ordering among the categories. Here are our categorical variables again. Now let's determine which are ordinal, have a natural order, and which do not, nominal. Satisfaction ratings on a scale from 1 to 5 would be ordinal, as there is a natural ordering for each individual on the scale from 1 to 5. Whether or not each individual has diabetes would be nominal, as there's no natural order. We're only categorizing into yes or no. Race, ethnicity, and gender are also nominal. The highest degree earned could be ambiguous, so let's assume it's generic in that it provides a list such as did not graduate high school, graduated high school, associate's degree, bachelor's degree, master's degree, higher than a master's degree. In such case, the highest degree earned and final letter grade would both have a natural order and would be classified as ordinal. Remember that nominal and ordinal are only choices for categorical variables. One special type of variable occurs when there are only 2 levels. Although this could be a count, 0 or 1, these variables are usually categorical in nature and are called binary or dichotomous variables. In our set of categorical variables above, diabetes and gender would be examples of binary variables, since there are only 2 possible levels. For quantitative variables, the 2 subclassifications are based upon the level of measurement. Discrete quantitative variables can take on only a countable number of values. There are gaps between the possible choices. These are usually count variables of some kind. Continuous quantitative variables can take on any value in an interval. Only our lack of need or lack of technology decides how precise we will or can measure these variables. Units should be provided with any analysis of continuous quantitative variables. Here are our quantitative variables again. Let's determine which are discrete, think countable, or continuous, think true measurement. In our set above, blood pressure measurements and body mass index would be clearly continuous. These are true measurements, limited only by our desire or ability to measure more precisely. Age and income in dollars would most likely be treated as continuous variables in most analyses, if there were a large number of possible values. Age is technically a continuous measurement, since it is lack of desire for precision that usually produces age in years. Income, however, could technically be considered to be discrete, as it is almost never divided beyond 1/10 of 1 penny. And finally, the number of emergency room visits and scores on a 5-question true-false quiz would be discrete, as these have a countable number of possible values.